guys, it's Mrs. Walker here again. I'm going to introduce myself every single time as if you don't know who I am, which is bananas. But anyway, I want to welcome you guys to kind of our first real online distance learning lesson. And the way that I'm structuring it right now is very simplistic. My setup back here is two towels, and I have a laptop on the floor, and I'm sitting in my screened porch. So here we go. But what I am hoping to do is to talk you guys through the presentation that I'm going to be putting on Google Classroom, and then talking you guys a little bit through Galileo. There's my dog. And then setting you guys up for an opportunity to do what's called a Galileo Gab Lab. So just so that you're aware, every day this week you're supposed to be doing about 30 to 45 minutes of science per day. And so that's kind of cutting our class down by half. And what that means is that it's kind of cutting my instruction by half too, because I really, as always, I want to prioritize the time that you guys have to do the actual activities and enrichment and investigations. So my goal for the next couple of weeks is to use the strategic plan of NASA kind of as the basis for this, because they have some different things in place that they have in their plans for people to learn. And so they've phrased it as discover and develop. So I think that that's going to work great for us in our current situation. I'm going to give you guys some discovery, and then I want you guys to develop those ideas wherever you're at. So on the first slide of the slideshow, I have this really interesting video. Okay, I think it's really interesting because it combines a couple of different things that in this unit we're going to see over and over again. And this image is from a few years ago. Hubble telescope pointed its scopes at a specific point in the sky. And this specific point in the sky, to our eyes, appears to be completely and totally dark. It's a point in space that is absolutely black from what we can tell. And a scientist who was at NASA fought really hard to look right at that spot for an extended period of time. And so they pointed Hubble telescope at it for a period of 10 days, which is a very long time to point Hubble at anything. And when they processed those images, what they saw was the most beautiful, clear picture of thousands of galaxies. And you can see all of the different galaxy structures, you can see the spirals, you can see irregular, you can see barred, hundreds of them in what appears to be a dark night sky. And what a composer did was he took that image and he assigned a tone to each different type of galaxy, and then moved it across it much like an old kind of wind-up music player, okay, music box. And what it has come from that is this really interesting space-age piece of music that I just think is a really cool way to start us all off as we head into space. So that's what's there first. Secondly, what I'm going to be talking to you guys about today is I'm going to be introducing Galileo. Okay, Galileo, 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 Magnifico. Let's sing it all together. We know what's up, right? And I'm going to be talking to you guys about Galileo, and then you all will be researching other famous historical astronomers as we get this unit kind of kicked off. So Galileo is a pretty fascinating guy. He's fascinating for lots of different reasons. He was definitely pretty quirky. We have a lot of documentation for Galileo, much in his own hand. It's all very first-person accounts of who he was. And so some fun things that he did first were some things called thought experiments, which if you have a very overactive imagination and you have some time on your hands right now, guys, which we all kind of do, you could do a thought experiment at home, which means you think your way through a scenario and then you change a couple of things about the scenario as your variables, and you think your way through it, and it's called a thought experiment. I have linked to a very specific thought experiment that he did if you want to check it out. So some other contributions that we attribute to Galileo, there are so many. He was not kind of a one-man show. He made great contributions in mathematics, in astronomy, in physical science, in mechanics. He was much like Da Vinci in that regard, in that he had his hands in lots of different things because he was just a very curious person. He was passionately curious. He is not credited with inventing either the telescope or the microscope, but he is credited with improving both of them significantly because of his study of how light moves through the eye and how light moves through space. That physical portion of the wavelength he really worked a lot with. He's also the guy that we can really thank for modernizing the scientific method. And that's huge, obviously, for any of the scientists out there. He wrote everything down, and his focus was on making it highly replicable. That it shouldn't look like magic, it shouldn't look like alchemy, it should look like a science. And to do that, it has to be uniform. And he's really credited first with the creation of this modern scientific method. He was also considered to be pretty funny. His writings are fairly humorous, and he did a lot in his notebooks that's highly interesting. The backgrounds of your presentation actually have his artwork in them that he had in his notebooks, which we'll talk about further in a few minutes. Moving on, I want to talk to you guys about Galileo's telescope so that you guys have the opportunity to do some more at home with a rudimentary scope. I'm going to actually kind of ask you to build one in a few minutes. So with Galileo's telescope, he worked with telescopes for many, many decades actually. And he was one of the first people to see the surface of the moon, which was his first thing that he was trying to really magnify. And he was quite successful using what are called rudimentary scopes. So that means they were not necessarily very sophisticated, but they definitely did work. Prior to us really being able to get a good look at the moon through telescopic data, we thought it was kind of structured like stalactites and stalagmites and very kind of a jagged surface. We know now, of course, that it is much closer to a barren wasteland of baking soda, okay? And that regolith, which is moon dust basically, it just goes on forever and ever and ever. While it's a rocky surface, it is definitely not very jagged. But he was able to see that through his telescopes because he was able to get close enough with his rudimentary scope that he could see how the mountains that are on the moon would cast shadows within craters. And so he was able to theorize that there were actually mountains and craters on the moon. And of course we know that he was correct. He also saw Jupiter's moons. He was the first to kind of draw in a documented way the Milky Way galaxy. He did not name it though. Of course, he was the first to document the lunar surface with his telescopes, and he also Saturn's rings first. So all of those are pretty fascinating. He spent a lot of time looking at the night sky, and you're next, kids. I have also linked, there's a portion at the bottom that says the Galileo missions, and what this is a collection of pages from his actual notebooks. You know, we notebook every day in our science class, and a lot of that is based off of the notebooking of scientists of years past. We've talked about Marie Curie's notebooks. We're talking about Galileo's. We're going to be talking soon about Sir Isaac Newton's. And these are powerful resources for documentation. So I do have that linked for you guys. Next is hopefully the fun part, which is during this strange time of social isolation and social distancing, it's important to me that you guys are still seeing each other, collaborating, talking if you can. The last thing that we want for you guys to feel right now is if you're all by yourself, because through the wonders of technology, nobody is really able nobody has to be alone. So I want to encourage you guys to do the Galileo Gab Lab, which is an opportunity for you guys to get online if you have different means of doing so. Of course, you probably know better than I do how to get these things going. But it would be nice if you guys could get together much like we would in class. Instead of talking across the table, you're just talking across the internet. And what I want you guys to do first is the assignment is laid out as you're going to do your historical astronomers research first. Galileo I have done for you, and you're going to write down the 3 most important things that you think that I've said from this in your notes, and then there are several other astronomers that you guys are supposed to be researching as well. Then I want you to go on a lens hunt. I know that that's a strange thing to say. But what I mean is that I want you to look around your homes, garages, yards, whatever, for things that you can use as lenses. Think outside the box here. I don't just mean a magnifying lens. I mean a cup with a flat bottom. It can be a lens. Mirrors can be used as lenses. A bowl, a glass bowl can be used as one. A vase, sunglasses. All of these things have lenses in them, and I want you to try and get at least 2 that you can work with, because what you're going to try and do is do exactly what Galileo did, and I want you to try and magnify the moon. So all you really need are at least 2 lenses. You can certainly do more, and it'd still be a rudimentary scope, and you need a clear night sky. And what I want you to try and do is to switch these lenses out a little bit and see if you can create a more magnified image of the moon. This would be a great thing to talk about with each other when this is over. So keep an eye on what you guys used. Make sure you note it in your notebooks. And then you guys can certainly talk back and forth to be like, hey, I had this and it was really, really useful. I didn't know if it would work. Or I went and got my grandpa's sunglasses and they worked great, because he can't read, because neither can I. I can't see y'all at all because I don't have my readers on. So I want you guys to play around and see if you can magnify the moon exactly like Galileo did, enough so that you can see both the mountains and the valleys. You ready? Let's do it. So the last slide on here is just a reminder about what it is that you guys are supposed to be doing, and then it says to stop. I want you to stop, because I have much more in this PowerPoint than we're doing today, or even really this week. I want to see how this kind of rolls out, and then I'll roll out the rest of the Hubble and the James Webb stuff down the road. But don't do it now. We're not ready for that yet. So don't worry about it. And also remember, on the lenses and on the Galileo telescope that you're trying to kind of replicate here, it might not work, and that's a-okay. That's just fine. If all you did was go out and take a good look at the moon, that's a worthy expenditure of your time. And our weather has been perfect. The night skies have been pretty clear so far, so I hope that that continues and that you guys are able to do this as well. Of course, you know I'm here. I'm here if you guys need anything. You can contact me via email. You can contact me via Google Classroom, and I'm going to try really, really hard to get right back to you as soon as I can. Keep up with the stuff that's in your notebooks. I'll have everything together in one assignment. So it'll be this lesson, it'll be the PowerPoint, and of course the ISN model pages. And you guys just let me know if there's anything else you need to be successful, and I'm here to help you. Okay? I hope you guys are all well. Go wash your hands. I love you. Bye-bye.